Good evening. For Calculus 1, Functions and Mathematical Modeling. Here we have two questions. Question number 1, find the domain of y is equal to x squared plus 5 over the square root of 9 minus x squared. For question number 2, we have find the domain and range of f of x is equal to 3x minus 2 over 5x plus 2. Now, to answer question number 1, we have y is equal to x squared plus 5 over square root of 9 minus x squared. Here we can see that we cannot assign a positive 3 to be the value for x because this rational function will become an undefined function. The denominator will definitely become 0. In the same manner that we also cannot assign a negative 3 for x because the denominator will also become 0. Also, we cannot assign numbers greater than or greater than positive 3 for x here because the denominator, which is a radical in radical notation, will become an imaginary number. In the same manner, we cannot also assign numbers that are lesser than negative 3 because it will also translate into the denominator will also translate into an imaginary number. But we can assign positive and negative real numbers for x. And so for the domain of x, we write for the domain of y, rather, we write domain of y is equal to x element of all positive and negative real numbers with the restriction that x should be greater than negative 3 and it should also be less than a positive 3. By interval notation, we have a negative 3 comma a positive 3 for the domain of y. And this means that the negative 3 and the positive 3 is not included in the possible values for x. For question number 2, we have find the domain and range of f of x, which is equal to 3x minus 2 over 5x plus 2. Okay, so for question number 2, we write f of x is equal to 3x minus 2 over 5x plus 2. Here, we cannot assign a negative 2 over 5 to be the value for x. Why is that? Because this rational function will be transformed into an undefined function. Okay? But we can assign other negative and positive values or negative and positive values which are the elements of real numbers for x. Okay, so we write the domain of f of x is x element of R, but x should not equal to negative 2 over 5. By interval notation, we have, so all the other numbers, all the other real numbers, negative and positive values, can be assigned to x, except negative 2 over 5. So by interval notation, we write negative infinity, comma, negative 2 over 5, union with negative 2 over 5, comma, positive infinity. So this is the interval notation for x should not equal to negative 2 over 5. Now, for the range of f of x, it is not easy to find the range of f of x without graphing. So, but instead of graphing, we would rather assign values for x and y so that by inspection we can already see the range for f of x. Now, graphing will be left for the students as an exercise. Now, we assign values for x and y for this particular rational function. Now, if we make x to be 0, y will become what? Negative 1. Now, if we make y, or if you make x rather equal to 1, then y will become 3 minus 2, 1, 5 plus 2, 7. And 1 over 7 by decimal value is equal to 0.14. If we assign 2 as the value for x, now we have 3 times 2, 6, minus 2, 4, over 5 times 2, 10 plus 2, 12. So we have 4 over 12, or which is equal to 1 over 3. By decimal value, we have 0.33. Now, if we assign 3 for x, we have 3 times 3, 9, minus 2, we have 7 for the numerator. And then 5 times 3 is 15 plus 2, we have 17 for the numerator. And its decimal value is closer to 0.41. Class, these are all continuous decimal values, or repeating, or a never-ending decimal places. Now, if we assign 4 for x, we get 4 times 3, 12, minus 2, 10. For the denominator, we have 5 times 4, 20, plus 2, 22, or 10 over 22, or we have 5 over 11. And this is almost equal to 0.45. Now, by inspection, we can see that all values of that the value of y is approaching 1/2. Right? 0.41, 0.45. This is the graph of a curve which is asymptotic to y is equal to 1/2. And so we write the domain, or the range for f of x, y is equal to the range of f of x is equal to y element of all the positive real numbers, and y all the positive, or we would rather we say all the positive and negative real numbers, but y is less than 1/2. Y can be negative, right? Because we have here a negative 1. Okay? And so by interval notation, we write negative infinity, comma, 1/2. So this is the interval notation for the range of f of x. Okay, that's it.